Good afternoon. My name is Zhi, a PhD student in the Internet Intelligence Research Lab at Georgia Tech, under the guidance of Professor Alberto Danotti. I'm honored and humbled to have the privilege of giving the last talk at this amazing conference. Today, I'd like to share our recent research findings on improving inference of sibling autonomous systems. As we all know, ASes are networks under the control of organizations, and when organizations might own and operate multiple ASes, which are called sibling ASes. Accurate inferences on sibling ASes to their owner organizations is essential for a variety of research topics. For example, if there are no indications of other malicious activities such as infiltration, then the BGP hijacking events between sibling ASes may be not particularly suspicious. And for other research topics like AS relationship inference, AS type classification, internet censorship monitoring, they all depend on accurate inferences of sibling ASes. The common practice of searching the information of a given AS number is to search on the Whois databases maintained by the 5 regional internet registries and some national internet registries. And another approach is to look up at the CAIDA AS-to-organization dataset, which is a structured dataset containing inferences of AS organization mappings based on the Whois data and some manual input. However, compiling an accurate dataset is not an easy task, and we have already found many inaccuracies in both Whois and CAIDA AS-to-org. For instance, the AS9426 is owned by Westpac Bank at Australia. However, both Whois and CAIDA AS-to-org map it to a big Australian telecom company, Syntel Optus. As a result, the AS is inaccurately classified as one of the 63 sibling ASes under this big telecom company. Another example includes 2 AWS ASes, which should be sibling ASes. However, the CAIDA AS-to-org does not recognize this and maps them to different organization objects. Such inaccuracies hinder the automatic and accurate research efforts. And when comparing the Whois data and CAIDA AS-to-org, we found there were few discrepancies between the two datasets, with differences in their mappings of less than 1%. And we also discovered that the inaccuracies in CAIDA AS-to-org mainly comes from the Whois data, which suggests that by understanding the root causes of Whois inaccuracies, we might have a chance to improve the inferences of sibling ASes. And our work makes several contributions. We leveraged PeeringDB as an additional data source and designed a pipeline to discover all the potential inaccuracies in CAIDA AS-to-org by checking the discrepancies of sibling inferences between PeeringDB and CAIDA AS-to-org. And we also conducted manual research on these inaccuracies, and we found 2 root causes of the inaccuracies in Whois databases. We also generated an improved dataset where we corrected the inferences related to more than 1,000 organizations and around 4,000 ASes. And we also proposed an automatic approach for efficiently reconstructing the improved dataset with 95% of fidelity. So in our work, it consists of a comprehensive manual research in an attempt to obtain the ground truth of sibling relations of the ASes involved in the discrepancies, where we contacted operators, reached out to the RIRs, searched on Google, checked the organization websites, matched the keywords. And during the process, we identified 2 root causes. One is called ethnic local internet registry issue. The other is multiple organization ID issue. The ethnic LIR issue comes from a special policy in the ethnic region. Different from other RIRs, the ethnic LIRs are also responsible to apply for AS numbers on behalf of their customers. Because ethnic considers the LIRs as resource holders, so the LIRs need to maintain the Whois data for their customers, and they have to put their own organization ID in the org ID field of ethnic Whois data. Well, they also put the actual owner's name in the description field. However, because CAIDA AS-to-org considers the org ID field as the only identifier of organization objects, the customer ASes of ethnic RIRs are inaccurately identified as siblings with other customer ASes under the same RIR. This is the exact reason behind the previous example of Westpac Bank. And the multi-org ID issue comes from like the organizations use more than one organization IDs for their ASes. And there are various reasons behind this. For example, the use of different org IDs for different subsidiaries or working groups, or the need of registering ASes under different RIRs. And in this case, it's impossible to use a single org ID for the RIRs delegated by different RIRs. For the ASes delegated by the different RIRs. Another reason is acquisitions and mergers. Because we understand that Whois databases are maintained mainly for the operational purposes, so it's not necessary for the operators to update the org ID field for the acquired ASes, but maybe updating the contact information or description or remark field should be enough. However, it's important for us to solve this problem in order to not miss any sibling ASes. And we corrected mappings for more than 1,000 organizations associated with around 4,000 ASes. Among these ASes, 15% of them were impacted by inaccurate sibling relations caused by the ethnic RIR issue, and the rest were missing some sibling ASes due to the multi-org ID issue. And because it's not scalable to carry out the manual research for each new release of CAIDA AS-to-org, we designed and implemented an automatic approach to update our improved datasets periodically. So if you want to learn more, please refer to our paper published at PAM 2023 and the GitHub repo of our improved dataset. Again, thanks you all for the patience and attention, and I would love to hear your thoughts and comments on our work. Thank you all.